The grandfather paradox. Can you erase yourself from time? Time travel is fascinating, but it creates serious logical problems. One of the most famous is the grandfather paradox. Imagine you go back in time and prevent your grandfather from meeting your grandmother. If they never meet, your parent is never born. And if your parent is never born, you can't exist. But if you don't exist, who traveled back in time to stop them from meeting? This paradox breaks the logic of cause and effect. Normally, a cause happens first and the effect follows. But if you change the past, you create a loop where your own existence erases itself. Philosophers have debated possible solutions to this paradox, the self-consistency principle. Some physicists, like Igor Novikov, suggest that the universe prevents paradoxes through self-consistency. If time travel is possible, then actions taken in the past must align with the present and future. This means you would never actually be able to change history in a way that prevents your existence. Your actions would always lead to events unfolding in a way that preserves the timeline. The parallel universes theory. This idea comes from quantum mechanics and the many worlds interpretation. According to this theory, when you change the past, you don't erase your own timeline. Instead, you create a branching timeline. In one timeline, your grandfather never meets your grandmother, and you are never born. Meanwhile, the original timeline where you do exist remains untouched. Time loops and determinism. Some theories suggest that events are locked in a deterministic cycle. If time loops exist, then anything you attempt to change in the past was already accounted for in the original timeline. In other words, every action you take in the past was always meant to happen, meaning you were destined to travel back, but never truly changed the outcome. The grandfather paradox raises a deep question. If altering the past creates logical contradictions, does that mean time travel is impossible? Or does it mean time behaves in ways we do not yet understand? No matter the answer, this paradox forces us to rethink time, causality, and free will. If traveling to the past ever becomes possible, we may finally discover whether paradoxes like this can be resolved or if they are an unavoidable limit of reality itself. The ship of Theseus paradox. When does something become new? At what point does something stop being itself and become something completely new? This is the question behind the ship of Theseus paradox, a classic thought experiment that challenges how we define identity and change. Imagine an ancient ship, cherished by its people and carefully maintained for generations. Over time, its wooden planks start to rot, and one by one, they are replaced with identical new ones. This process continues until eventually, every single plank, nail, and rope has been swapped out. Now, here's the dilemma. The ship still looks the same, but is it really the same ship? Or has it become something entirely different? This idea doesn't just apply to objects, it applies to you. The human body constantly renews itself. Cells die and regenerate, your thoughts shift, your memories fade and reform, and your personality evolves. If every part of you changes over time, are you still the same person you were years ago, or have you become someone new? Some argue that identity is about continuity, not individual parts. As long as change happens gradually, the ship remains the ship of Theseus, just like a person remains the same despite physical and mental transformations. Others disagree. They say that once every part has been replaced, the original no longer exists. What's left is only a replica. The paradox gets even stranger when we ask, what if we took all the old discarded pieces and rebuilt them into a second ship? Now, which one is the real ship of Theseus? The one that stayed intact but changed over time, or the one made from the original parts? This puzzle applies to more than just ships and people. It raises questions about artificial intelligence, traditions, and even entire nations. It forces us to ask whether identity is a fixed essence or something fluid, shaped by time and transformation. If something constantly changes but still feels like the same thing, does that mean identity is just an illusion? The ship of Theseus makes us rethink what it means to exist over time. Whether we apply it to objects, people, or societies, it leaves us with one unsettling question. How much can change before something stops being what it once was? Zeno's paradoxes. Can motion even exist? At first glance, motion seems obvious. We walk, run, and drive without question. Yet, over 2,000 years ago, the philosopher Zeno of Elea proposed a series of paradoxes that challenged the very concept of movement. If his reasoning is correct, then motion itself may be nothing more than an illusion. One of his most famous paradoxes is Achilles and the tortoise. Suppose the great warrior Achilles races against a slow-moving tortoise, giving the tortoise a small head start. Zeno argued that before Achilles can overtake the tortoise, he must first reach the point where the tortoise started. But by the time he reaches that point, the tortoise has moved slightly forward. Achilles must now reach this new position, but again, the tortoise has advanced. This process continues infinitely, implying that Achilles can never actually catch the tortoise, no matter how fast he runs. Another paradox, the dichotomy, claims that in order to move any distance, one must first reach the halfway point. But before reaching halfway, one must reach a quarter of the way, then an eighth, and so on. Since this sequence divides the journey into an infinite number of steps, it suggests that reaching any destination is impossible. Zeno's arguments challenge our understanding of infinity and division. If space and time can be divided infinitely, does that mean motion requires completing an infinite number of steps? And if so, how do we move at all? For centuries, these paradoxes puzzled philosophers and mathematicians. The advent of calculus provided a resolution, suggesting that infinite sums can converge to a finite result, meaning that Achilles does overtake the tortoise. However, Zeno's paradoxes remain relevant in modern physics, particularly in quantum mechanics and the nature of space-time. Ultimately, Zeno forces us to reconsider the nature of movement. Is it continuous, or is reality composed of discrete, indivisible moments? If motion is an illusion, what does that mean for our experience of time and space? The bootstrap paradox. Can something exist without an origin? The bootstrap paradox is a troubling thought experiment that challenges our understanding of cause and effect. It describes a situation in which an object, idea, or piece of information exists without ever having been created. Instead of having a clear origin, it loops endlessly in time. Imagine a person finds an old book containing detailed instructions on how to build a time machine. They follow the instructions, construct the machine, and travel back in time to give the book to their younger self. The younger version then grows up, follows the instructions, and repeats the cycle. But who wrote the book in the first place? If it was simply passed back and forth through time, it seems to have materialized from nowhere. This paradox extends beyond books to other objects, knowledge, and even people. A musician could learn a song from an older version of themselves, then travel back and teach it to their younger self, creating a loop where the song exists but was never originally composed. If a scientist from the future gives blueprints for an invention to an engineer in the past, and that invention becomes widely known, who actually invented it? The bootstrap paradox defies conventional logic because it breaks the fundamental principle of causality. Every effect must have a cause. In a normal sequence of events, something is created at a specific point in time. But in this paradox, the object or information has no identifiable origin, existing only because it is continuously transferred through time. Some interpretations suggest that time might be consistent, meaning paradoxical loops like this could exist without contradiction. Others argue that such loops are impossible and that something, some external factor, must intervene to ensure causality remains intact. The paradox raises profound questions about time, information, and reality. If an object can exist without an origin, does that mean reality itself could be caught in a loop? Could our own existence be the result of an event with no clear beginning? And if so, is there ever a true source of anything? The omnipotence paradox. Can an all-powerful being create a rock it cannot lift? The omnipotence paradox is a famous question in philosophy. It challenges the very idea of unlimited power. The question is simple. If an all-powerful being exists, can it create a rock so heavy that even it cannot lift it? If the answer is yes, then there is something the being cannot do, lift the rock. If the answer is no, then there is something the being cannot do, create the rock. Either way, it seems there is a limit to its power. This creates a contradiction, which challenges the idea of true omnipotence. For centuries, philosophers and theologians have debated this paradox. It raises deep questions about logic, power, and the nature of a supreme being. One major question is whether omnipotence includes the ability to do logically impossible things. Can an all-powerful being create a square circle? Can it make 2 + 2 = 5? Some argue that true omnipotence means the ability to do anything that is logically possible, but not actions that contradict themselves. By this logic, the rock paradox is meaningless because it creates an impossible situation. Others believe the paradox is only a language trick. They argue that omnipotence means being able to do all possible things. Asking if an all-powerful being can limit itself is like asking if it can stop being all-powerful. It's just playing with words rather than exposing a real flaw. The paradox also raises bigger questions. Can an all-powerful being impose limits on itself? If it does that mean it is no longer truly omnipotent? Or does having the power to limit itself still count as unlimited power? Ultimately, the omnipotence paradox forces us to rethink what power really means. Does true omnipotence require the ability to perform the impossible? Or is even an all-powerful being bound by logic? And if the very idea of unlimited power leads to contradictions, does that mean true omnipotence is impossible? This paradox may never have a final answer, but it remains one of the most thought-provoking challenges to the idea of absolute power. The quantum suicide paradox. Is there a reality where you always survive? The quantum suicide paradox is a thought experiment based on the strange and counterintuitive rules of quantum mechanics especially the many worlds interpretation. This idea suggests that if the universe constantly splits into different timelines, there could always be a version of you that survives, no matter what happens. To understand this paradox, imagine a scenario where a person is placed in front of a machine that is controlled by quantum mechanics. This machine has a 50% chance of firing a lethal shot and a 50% chance of doing nothing. The outcome is determined by the state of a quantum particle, meaning the result is completely random at the quantum level. Now, here's where it gets strange. Every time the machine is activated, the universe splits into two. In one version of reality, the person is unharmed. In the other, they die. For outside observers, this looks normal. They see the person survive sometimes and die at other times. But from the perspective of the person in the experiment, they never actually experience their own death. In every reality, they remain aware and continue to survive, no matter how many times the machine is triggered. This means that, from their point of view, they are effectively immortal. This paradox challenges everything we think we know about life and death. If the many worlds interpretation is correct, does that mean no one ever truly experiences death? Instead of ceasing to exist, do we simply continue in a version of reality where we miraculously survive? And if that is true, does it mean everyone is, in some sense, immortal in at least one timeline? The quantum suicide paradox raises deep philosophical and ethical questions. If infinite versions of us exist, what does that mean for our identity? If we always continue in some reality, does death even matter? And if we are trapped in an endless series of survivals, does it mean we are doomed to exist forever? The implications of this paradox go far beyond physics. They force us to rethink what it means to be alive and what it truly means to die. The observer effect. Does seeing change what is seen? In everyday life, observing something seems passive. We watch events happen without interfering. But in quantum mechanics, the observer effect suggests that the very act of looking at something can change it. This idea raises deep questions about reality and whether anything can exist independently of observation. A famous example of this is the double-slit experiment. In this experiment, scientists fire tiny particles, such as electrons or photons, at a barrier with two narrow openings called slits. If no one measures which slit a particle passes through, it behaves like a wave, spreading out and creating an interference pattern on a detection screen. But when scientists place a measuring device to check which slit the particle goes through, something strange happens. The particle no longer behaves like a wave. Instead, it behaves like a solid object, going through just one slit and destroying the interference pattern. This means that the act of measuring the particle changes its behavior. It is as if the particle somehow knows that it is being observed. This challenges the way we normally think about objects. In classical physics, things have definite properties, whether we look at them or not. But in quantum mechanics, particles exist in multiple possible states at the same time. This is called superposition. They only choose a definite state when they are observed. But what does this mean outside of quantum physics? Could reality itself depend on being observed? This paradox has led to many interpretations. 1. Consciousness shapes reality. Some suggest that consciousness plays a role in shaping reality. This would mean that, without observers, the universe itself might not exist in any definite form. 2. reality is already determined. Others believe that observation does not actually change reality, but simply reveals an outcome that was already determined. One of the most well-known interpretations of quantum mechanics is the Copenhagen interpretation, which suggests that reality remains undefined until it is measured. Another interpretation, called the many worlds theory, suggests that all possible outcomes still exist, just in separate branches of reality. The implications of the observer effect go beyond physics. They touch on deep philosophical questions. If observing something changes it, does that mean reality is connected to our perception? Is an unobserved world real in any meaningful way? Or does existence require an observer? And if consciousness affects reality, how far does this connection go? This paradox forces us to rethink our understanding of the physical world. If observation shapes reality, then what does that say about existence itself? Is reality something external and objective, or does it only take form when we look at it? The simulation paradox. If we could be in a simulation, how would we know? What if everything you see and feel, your thoughts, your memories, even the entire universe, is nothing more than a highly advanced simulation? The simulation paradox asks whether we could ever truly tell the difference between a simulated reality and an actual one, or if we are forever trapped inside an illusion we cannot perceive. This idea became widely known through philosopher Nick Bostrom's simulation hypothesis. He suggests that a highly advanced civilization could create simulated worlds so realistic that the conscious beings inside them would have no idea they were simulated. If such a civilization existed and ran multiple simulations, then the number of simulated realities would far outnumber the original real world. That means, statistically, it is more likely that we are in a simulation than in the original base reality. If that is true, how would we ever know? Some physicists believe there may be clues hidden in the laws of physics. They suggest that glitches in the fabric of reality, such as strange patterns in cosmic radiation or fundamental limits on how much information the universe can process, could be signs that we are inside a programmed environment. Others argue that consciousness itself might function like software running on an unknown system. We can never directly observe the hardware, so our sense of free will and individuality could just be part of the program. But here's the paradox. If we are in a simulation, then everything we experience, everything we measure, and everything we try to test is happening inside the simulation. That means any attempt to detect the simulation is still governed by its rules. If the simulation does not want us to find out, it could prevent us from ever discovering the truth. Just as a character in a video game cannot comprehend the computer it runs on, we may be fundamentally unable to perceive anything beyond the boundaries of our own simulated universe. This raises disturbing questions. If we are in a simulation, does anything we do actually matter? Is there a real world beyond this one? If there is, what role do we play in it? And if some higher intelligence created us, does that make it our God most unsettling of all? If we somehow found proof that we were in a simulation, what would we do with that knowledge? The simulation paradox forces us to confront the nature of reality itself. If a simulation is so perfect that we cannot tell the difference, then what does real even mean? The identity paradox. Are you the same person you were a year ago? What does it mean to be you? At first, the answer seems obvious. You are the same person you were yesterday, last year, or even a decade ago. But upon closer examination, the identity paradox reveals that personal identity is far from simple. If everything about you changes over time, at what point do you stop being the same person? Physically, your body is in constant flux. Cells die and regenerate, and over the course of several years, nearly every atom in your body is replaced. If none of the matter that made up your body 10 years ago remains, can you still say you are the same person? Or have you become an entirely new being while retaining the illusion of continuity? The paradox extends beyond the physical and into the mental. Your thoughts, beliefs, memories, and desires shift with time. The way you think and feel today may be completely different from how you thought and felt in the past. If identity is based on memory, what happens when memories fade or are altered? And if identity is based on personality, what about cases where brain injuries or psychological changes make someone unrecognizable in terms of behavior? Some philosophers argue that identity is an illusion. They suggest that what we call the self is nothing more than a constantly shifting stream of experiences, with no core essence. Others believe that identity persists because of continuity. They claim that as long as changes occur gradually and not all at once, a person remains the same. But this raises another issue. If someone were instantly cloned with all their memories and personality traits intact, which one would be the real version? The original or the clone? The identity paradox forces us to rethink the nature of the self. If everything about you, physically and mentally, evolves over time, what is it that remains constant? Are we truly the same person throughout our lives? Or is personal identity just an illusion we create to maintain a sense of continuity? The paradox of the mind. Is consciousness an illusion? Few things feel as undeniable as consciousness, the experience of thinking, feeling, and being aware. Yet the paradox of the mind challenges this assumption by asking whether consciousness is real or an illusion produced by the brain. At its core, the paradox arises from the hard problem of consciousness. Why and how does subjective experience emerge from physical processes? The brain consists of neurons firing electrical signals, following the laws of physics and chemistry. But nothing about these interactions seems to explain why we experience thoughts, emotions, and sensations. Could consciousness simply be a byproduct of biological computation? Or is it something deeper, a fundamental property of the universe? Some philosophers argue that consciousness is an illusion, a trick of evolution that gives us the false sense of an inner self. This view, known as eliminative materialism, suggests that just as science has replaced outdated notions like vitalism, the idea of a life force, it may one day reveal that consciousness is nothing more than a useful fiction. From this perspective, what we call experience is simply the brain processing information in a way that creates the appearance of awareness. On the other hand, some theories propose that consciousness is a fundamental property of the universe, not reducible to neural activity. Panpsychism, for example, suggests that consciousness is woven into the fabric of reality, existing even at the level of elementary particles. If true, this would mean that the mind is not an illusion, but an intrinsic aspect of existence itself. The paradox forces us to ask unsettling questions. If consciousness is an illusion, who or what is being deceived? If it is real, why does it seem so different from everything else in the physical world? And if we ever fully understood the nature of consciousness, would that change our sense of self? Ultimately, the paradox of the mind highlights the biggest mystery of all, our own awareness. Whether consciousness is a fundamental truth or an elaborate illusion, it remains the most perplexing aspect of human existence. The perception paradox. Why reality isn't what it seems. What if I told you that the way you see the world isn't the way it really is? That your reality is shaped by something far beyond just facts? This is the perception paradox. The idea that two people can look at the same thing and see something completely different. And here's the shocking part. Both of them are right in their own way. Your brain isn't a camera. It doesn't just record reality. It filters, interprets, and even fills in gaps based on your past experiences, emotions, and biases. That's why two people can watch the same event and remember it differently. Think about eyewitness testimonies in court. Studies show that people recall the same crime scene differently based on their background, beliefs, and even their mood at the time. But perception isn't just shaped by your brain. The world around you, media, culture, and social influence creates an invisible lens through which you see reality. In politics, two people can hear the same speech, yet one finds it inspiring, while the other finds it manipulative. Why? Because they're not just hearing words, they're interpreting them through their own experiences and beliefs. Here's where it gets tricky. We all believe we see the world objectively, but the truth is, we're all seeing a version of reality shaped by our own minds. And the real paradox? The more certain we are about our own perception, the harder it becomes to see other perspectives. So how do we break free? It starts with realizing that perception is not reality. It's just our reality. The more we challenge our own beliefs, the clearer we see the world. The perception paradox isn't about proving who's right or wrong. It's about understanding that we all see through different lenses. And when we open our minds, we see more than just the world. We see truth. Reality is what we make of it. Keep questioning. Keep learning. The forgotten existence paradox. Do we truly exist? What if I told you that one day, everything you are, your thoughts, your memories, your entire existence will be forgotten? That no matter how much you achieve, how much you love, or how deeply you impact the world, one day it will all fade into nothingness? This is the forgotten existence paradox, the unsettling reality that while we live believing our existence matters, in the grand scheme of time, we are destined to be forgotten. Think about it. How many people from 100 years ago do you remember? A few famous names, maybe. But what about the billions of others who lived, loved, and dreamed just like we do? Their stories, their struggles, their very existence, erased from history. And yet, while we know this, we live as if it isn't true. We chase meaning, build relationships, and strive for greatness. Why? Because despite knowing that time will forget us, we cannot escape the feeling that our existence matters. Here's the paradox. If we are destined to be forgotten, does anything we do truly matter? Or is the very act of living, creating, and loving what gives life meaning, even if it's temporary? Maybe the purpose of existence isn't to be remembered forever. Maybe it's simply to exist now, to embrace the moment, and to leave ripples, however small, in the vast ocean of time. Because in the end, it's not about being remembered, it's about having lived. The teletransportation paradox. Are you still you? Imagine stepping into a machine that scans every atom of your body, destroys the original you, and rebuilds an identical version on the other side. Same memories, same personality, same DNA. But here's the question. Did you survive the process, or did the original you just cease to exist? This is the teletransportation paradox, a thought experiment that challenges our understanding of identity and consciousness. If every part of you is perfectly reconstructed, does it mean you are still the same person? Or is this new version just a flawless copy, while the real you is gone forever? Think about it. Every cell in your body naturally replaces itself over time. The person you were 10 years ago is physically gone, yet you still feel like you. But in teleportation, the change happens instantly. Does continuity matter, or is identity just an illusion? Here's where it gets unsettling. If you teleport and an identical version appears somewhere else, what if the machine fails to destroy the original? Now, there are two of you. Who is the real one? And if you could exist in two places at once, was your sense of self ever real to begin with? The paradox forces us to ask, are we just biological machines, defined by our physical structure? Or is there something more, something that makes you, you? And if science ever makes teleportation possible, would you step inside the eternal recurrence? Would you live your life again? What if, after you die, you wake up, only to live your entire life again? Every choice, every mistake, every joy and pain playing out exactly the same way. Not just once, but over and over for eternity. This is the idea of eternal recurrence, a thought experiment that asks, if you had to relive your life infinitely without changing a single thing, would you be proud or horrified? Think about it. Every action you take, every word you speak, every moment you waste. Would you still choose the same path if you knew you'd experience it forever? The paradox is this. If eternal recurrence is real, then every second of your life holds infinite weight. Every small decision echoes through eternity. So, are you living in a way that you'd be willing to repeat forever? Or would you wish you had lived differently? The time travel paradox. Can you change the past? Imagine you step into a time machine and travel back in time. You make one small change. Maybe you prevent an accident or give advice to your past self. But here's the problem. If you change the past, wouldn't that alter the future, including the very reason you traveled back in time? This is the time travel paradox, a mind-bending loop where cause and effect break down. Take the grandfather paradox. If you travel back and prevent your grandfather from meeting your grandmother, you would never be born. But if you were never born, then who went back in time to stop it? Or consider the bootstrap paradox. Imagine you travel back and give Shakespeare his own plays. If Shakespeare only wrote them because he got them from you, then who actually created them? These paradoxes reveal a deep mystery. If time travel is possible, does that mean the past is fixed, unchangeable? Or does every change create a new reality, splitting time into infinite possibilities? And if time travel ever becomes real, would you dare to rewrite history? The paradox of self-deception. How can you fool yourself? Self-deception is a strange thing. How can a person lie to themselves and still believe it? If you know the truth deep down, then aren't you just pretending? But if you don't know you're lying, then how did the deception start in the first place? This is the paradox of self-deception, the idea that we can knowingly believe something false while simultaneously hiding the fact that we know it's false. It's a contradiction, yet we do it all the time. How does self-deception work? At first glance, self-deception seems impossible. How can the same mind both create a lie and believe it? But our brains don't work like a simple logic system. Instead, they are layered, with different parts processing information separately. Psychologists suggest that our mind can split into a knowing part and a believing part. The knowing part detects the truth, but the believing part suppresses or distorts it to protect us from discomfort, fear, or guilt. For example, a smoker might know that smoking is harmful, but convinces themselves that it's not that bad. A student who fails an exam might know they didn't study enough, but instead blame an unfair teacher. In both cases, the truth exists, but the person alters their perception to avoid facing it. The real danger of self-deception. The paradox becomes more troubling when self-deception lasts too long. The more we lie to ourselves, the more we reinforce those false beliefs. Over time, we might genuinely forget the truth, losing sight of reality altogether. Consider a person stuck in a toxic relationship. Deep down, they know they are unhappy, but they convince themselves that things will get better soon. Years pass, and they remain trapped, not because of reality, but because of the false reality they created. Is self-deception always bad? Surprisingly, self-deception isn't always harmful. In some cases, it can help us survive and push forward. Athletes, for example, often convince themselves that they are unstoppable, even when the odds say otherwise. This belief, though technically false, can fuel confidence and lead to victory. Similarly, people facing extreme hardships might deceive themselves into believing they have hope, even when logic says otherwise. And sometimes that belief is exactly what helps them survive. Breaking free from the paradox. The key to escaping self-deception isn't to stop fooling ourselves entirely. It's to recognize when our lies are helping us versus when they are holding us back. Ask yourself, what uncomfortable truth am I avoiding? What belief do I cling to, even when evidence says otherwise? Is my self-deception protecting me or trapping me? Because at the end of the day, the most dangerous lies aren't the ones we tell others, but the ones we tell ourselves. The reverse time paradox. What if time ran backward? Time, as we experience it, moves in one direction, from past to present to future. But what if time didn't work that way? What if time could flow backward, undoing everything that has happened? Would events still make sense? Would cause and effect still exist? This is the reverse time paradox, a mind-bending idea that challenges our very understanding of reality. Why does time move forward? In physics, most fundamental laws, like Newton's laws of motion, don't actually require time to move in a single direction. If you watch a ball rolling forward, the equations work just as well if you reverse the motion. So why do we always experience time moving forward and never backward? The answer lies in something called entropy, a concept from the second law of thermodynamics. Entropy is a measure of disorder, and according to physics, the universe always moves toward higher entropy. That's why a glass can fall and shatter into pieces, but the shattered pieces never reassemble into a perfect glass. If time ran in reverse, entropy would decrease, meaning everything would become more ordered instead of more chaotic. But here's the paradox. The universe started in a very low entropy state, the Big Bang. So if time reversed, we'd be heading toward that perfect order. Would that mean memories would unform, people would grow younger, and effects would come before causes? The grandfather paradox in reverse time. The famous grandfather paradox of time travel asks, what happens if you travel back in time and prevent your grandfather from meeting your grandmother? If you do that, you would never be born. But if you were never born, how could you go back and stop them from meeting? Now, imagine this in reverse time. Instead of causing an event, you are now uncausing it. If you are walking forward in time, you make decisions that shape your future. But in reverse time, do you unmake those decisions? Would your thoughts and actions be undone the moment you complete them? For example, if you drop a glass in reverse time, the shattered pieces would float up and perfectly reassemble in your hand. But in that world, would it feel normal to you, or would it seem as absurd as it does to us in forward time? What would it be like to live in reverse time? If you lived in a universe where time ran backward, everything would appear completely normal to you. Just as we think moving forward in time is natural, you would perceive reverse time as normal because your memories, thoughts, and actions would also be reversed. Instead of eating food, you would spit it out onto your plate piece by piece. Instead of speaking, words would be sucked back into your mouth. Instead of being born, you would start as an old person and grow younger until you disappeared into non-existence. From our perspective, this seems completely unnatural. But if time has always been reversed in that world, would the people living there think our forward time was the real paradox? The real question: is time even real? If physics doesn't require time to move forward, and if reverse time seems just as mathematically possible, then why do we experience time at all? Some physicists argue that time is an illusion, a byproduct of how we perceive the universe, rather than a fundamental property of reality. In some advanced physics models, time is just another dimension, like height, width, and depth. If that's true, then what we think of as the present might be nothing more than a slice of a four-dimensional universe where past, present, and future all exist at once. And if time can move in reverse just as easily as it moves forward, then maybe, just maybe, we are already trapped in an infinite loop of existence, moving through time without ever truly understanding what it is. Schrödinger's cat paradox. Can something be alive and dead at the same time? Imagine a closed box. Inside, there's a cat, a vial of poison, and a radioactive atom. The atom has a 50% chance of decaying within an hour. If it decays, the poison is released and the cat dies. If it doesn't, the cat stays alive. Now, here's the paradox. Until you open the box, you don't know whether the cat is alive or dead. According to quantum mechanics, until it is observed, the cat is in a state of superposition. It is both alive and dead at the same time. This is Schrödinger's cat paradox, a thought experiment proposed by physicist Erwin Schrödinger in 1935 to illustrate the strange nature of quantum mechanics. The quantum mystery, superposition. At the atomic level, particles don't behave like solid objects. Instead, they exist in multiple states at the same time, a phenomenon called superposition. Only when we measure them do they collapse into a definite state. For example, an electron doesn't have a fixed position until we observe it. It exists in a cloud of possibilities. Similarly, The cat is neither fully dead nor fully alive until we open the box and check. But this raises a troubling question. Does reality exist independently of observation? If a particle, or a cat, is in multiple states at once, does that mean observation itself decides reality? The observer effect. Do we create reality? One interpretation of quantum mechanics suggests that the act of observing something determines its state. This means that before we observe the cat, it exists in both states. But when we look inside the box, we force reality to choose one outcome. But if this is true, then does reality even exist when no one is looking? Is the universe shaped by observation, or does it function on its own? Parallel universes, the many worlds. Interpretation. Another way to resolve the paradox is the many worlds interpretation. This theory suggests that both possibilities happen, but in separate universes. In one universe, the cat is alive. In another universe, the cat is dead. Every time a quantum event occurs, reality splits into multiple branches, creating infinite parallel universes. If this is true, then every decision you make creates a new version of reality. Right now, there could be infinite versions of you living in alternate timelines, each experiencing a different outcome of every choice you've ever made. What does Schrödinger's cat teach us? Schrödinger's cat isn't just about a cat in a box. It's about the nature of reality itself. It challenges our understanding of existence, observation, and the role consciousness plays in shaping the universe. Is reality objective and independent? Or is it shaped by the act of observing it? The answer remains one of the biggest mysteries in physics. So, the next time you make a decision, ask yourself, how many versions of reality did I just create? The twin paradox. Can time move slower for one person? Imagine two identical twin brothers. One stays on Earth, while the other boards a spaceship and travels at near the speed of light to a distant star. After several years, the traveling twin returns. But here's the shocking part. He is younger than his twin who stayed on Earth. This is the twin paradox, a famous thought experiment in Einstein's theory of relativity, which challenges our understanding of time. Why does this happen? Time dilation. According to Einstein's special theory of relativity, time is not absolute. It moves at different speeds depending on how fast you are moving. This effect is called time dilation. The faster you travel, the slower time moves for you relative to someone who is stationary. If you move at close to the speed of light, time slows down drastically for you compared to someone on Earth. So, for the twin traveling through space, time ticks slower compared to the twin on Earth. When he returns, he has aged much less than his earthbound brother. Is this a paradox? At first, this seems like a paradox because motion is relative. You could argue that the traveling twin sees himself as stationary while Earth is moving away at high speed. So why doesn't the Earth twin experience time dilation instead? The answer is that the traveling twin is not in an equal situation. He undergoes acceleration and deceleration when he turns around to come back to Earth. This breaks the symmetry. His journey involves changing reference frames, while the twin on Earth stays in a single reference frame. This means the effects of relativity are not the same for both twins, and the traveling twin truly does age more slowly. Real-world proof. Time travel in action. The twin paradox isn't just theoretical. It has been proven using atomic clocks on airplanes and satellites. In 1971, scientists flew atomic clocks around the world on jets and compared them to clocks on the ground. The moving clocks ticked slower, exactly as predicted by relativity. GPS satellites orbiting Earth experience time slightly faster than clocks on Earth due to weaker gravity, but slower due to their high speed. If we didn't adjust for these effects, GPS navigation would become completely inaccurate. What does this mean for the future? The twin paradox shows that time travel into the future is possible. If we ever build spacecraft that can travel near the speed of light, astronauts could experience days or months while thousands of years pass on Earth. If you traveled at 99.999% the speed of light for just 5 years, when you return, Earth would be thousands of years into the future. You would have effectively traveled through time. So, the next time someone asks if time travel is real, the answer is yes, just not in the way you might think. The omniscience paradox. Can an all-knowing being have free will? Omniscience means knowing everything, past, present, and future. But if a being, like God, knows everything that will ever happen, does that mean the future is already determined? And if the future is predetermined, does an all-knowing being have free will to change anything? This is the omniscience paradox, a deep philosophical and theological puzzle that challenges the very nature of knowledge, destiny, and free will. The paradox explained 1. An omniscient being knows everything, including its own future actions. 2. But if it already knows what it will do, then it cannot choose to do anything else. 3. If it cannot choose, does it really have free will? 4. But if it does have free will and can change its actions, then its prior knowledge was wrong, which means it wasn't truly omniscient. So, which is it? Perfect knowledge or free will? Can both exist at the same time? The free will versus determinism problem. The paradox also affects humans if we believe in an all-knowing God. If God already knows everything you will do, are you truly free to make choices? If your choices are not free, then how can you be held responsible for them? But if you do have free will, does that mean God's knowledge of the future could be wrong? This is the core of the free will versus determinism debate. If everything is already known, does that mean everything is predestined? Or is knowledge simply an awareness of what will happen without controlling it? Possible solutions to the paradox 1. Timeless knowledge. Some argue that an omniscient being exists outside of time, meaning it doesn't predict the future, but simply sees all of time at once. This means free will can still exist because the being is not forcing events, just witnessing them. 2. Middle knowledge, Molinism. This idea suggests that an omniscient being doesn't just know what will happen, but also what could happen under different circumstances. This allows for free will while still keeping divine knowledge intact. 3. Knowledge doesn't equal control. Just because an omniscient being knows what will happen doesn't mean it is forcing it to happen. A chess grandmaster might know every possible move you could make, but that doesn't mean you don't have a choice. The big question: if an all-knowing being already knows everything, then does it ever learn anything new? Can it change its mind? Can it experience surprise or discovery? And if it can't, does that make omniscience a limitation rather than a power? The omniscience paradox forces us to rethink our ideas about knowledge, destiny, and what it truly means to have free will in a universe where everything might already be known.